Hey there, this is Nicholas Facciola with Team 67, and this is the first video in the video walkthroughs for CSE 365 Spring 2020 Final Exam. And in this video, I'm going to be demonstrating how to solve the Affine Cipher challenge step by step. So basically, when you read the description, it says, time for a crypto challenge. This is the best cipher, this is a great cipher, this is a fine cipher. The huge hint in this description is this last line, which says this is a fine cipher. I did some research, and there's actually a type of encryption algorithm called an affine cipher. And in that research, I was able to find the actual encryption algorithm for that. I was actually able to find the encryption algorithm for that type of ciphertext. So I'm going to be demonstrating that here, and I'm going to show how you can use that to actually get your plain text back, decrypting it. So essentially, to encrypt plain text into an affine cipher text, you're going to use the equation y equals alpha times x plus beta, where this y is your ciphertext, and this x is your plain text. So from here, you can see that if you were to solve this equation for x instead of y, you would actually get the decryption algorithm instead of the encryption algorithm. And we can try different values of alpha and beta by brute force until we find something that looks like English that we can use for our flag. So solving for x, you're going to get y minus beta equals alpha times x, and you're going to divide both sides by alpha. So you're going to get y minus beta equals, over alpha equals x. And finally, you can write it as alpha to the -1 times y minus beta equals x. So this is your decryption algorithm solved for from your encryption algorithm. And like I said before, we can use different values of alpha and beta until we find our plain text from our given ciphertext. So I'm going to go back to the challenge and download this ciphertext, and you can tell it's ciphertext because obviously you can't read that in English. So instead of doing all the calculations by hand, I actually found this website called Practical Cryptography, where there's some JavaScript code that actually goes through and it shows you how to do the algorithm step by step and how to encrypt and decrypt it. But the code is already written for you. So what I'm going to do is paste this ciphertext, and we're going to try different values of alpha and beta until we get some text that looks like English. So at least in the room close. So just keep trying. You can tell that none of these are working. Oops. And just keep going down the line until we find something close. And we could stop here because we can tell that if you split this up, this says, isn't this a fine cipher? This is actually we can tell that this is actually the text that we want for our flag. So I'm going to go back, and I am going to copy and paste this plain text. And a challenge, all you have to do now is follow the flag format, make sure we submit it correctly. It's going to say that I already solved it. But if you hadn't solved it, this is what you would enter in for your flag. And there you go. You solved the Fine Cipher challenge. So with this, you want to know if you wanted to send a message to somebody in the real world, what would be the actual way you would want to hide your secret message, because this challenge was obviously very simple for the attacker to figure out the algorithm and decrypt the ciphertext and go back and get the plain text. So as far as cryptographic algorithms are concerned, the easiest answer is to just not use them, because if you're going to be using a cryptographic algorithm such as a Vigenère cipher, a Caesar cipher, in this case an Affine cipher, it's going to be very simple if you know the algorithm for the attacker, if they intercept your message, to go back and reverse it and figure out the plain text. So what you actually want to be using if you're going to be trying to send a message to somebody and keep it secret is a cryptographic hash function. So essentially, this is better because it's really easy to compute, but it's hard to go back. And this brings us to public key cryptography, which basically states that, like, if I had a message that was secret and said I wanted to send it to my friend Joe, just say his name is Joe, but I didn't want Bob to see it. If I encrypt the message using Joe's public key, he was easily able to decrypt it using Joe's private key, but Bob does not have access to Joe's private key, only Joe's public key. So this allows me to send a message to Joe without Bob seeing it. And there is no way that Bob would be able to, just do some simple algebra and figure out a method to go back and reverse the message. Yeah, so that is the simplest way, or not, I guess not necessarily the simplest, but the best way to hide this vulnerability that it is associated with cryptographic algorithms. Okay, thank you.